Thinking about neutralization reactions and acids and bases as reactants naturally leads us to titrations. Titrations can involve lots of different types of reactions, precipitations, redox, but they're most common with acid-base neutralizations. We have a known either acid or base, and we use that to analyze an unknown, either solid or solution, to find its moles, to find its molar mass, to find its molarity. With titrations, it's important to remember that it's all about precision, using specific, precise glassware like burettes and volumetric pipettes, rinsing them with the solution to make sure that the solution has a very exact concentration, and understanding what it means if we added too much or too little of something. The error analysis is very common. But any type of titration is all about finding the equivalence point. The equivalence point for acid base, sometimes we would say, is where we are neutral, but as we've just seen, it's not necessarily a neutral solution. It is where the moles of the acid are equivalent to or equal to the moles of base, the hydrogen and the hydroxide. The other way we could think about this is initially one of our reactants is an excess, and the other one we're adding just a little bit at a time. It's the limiting. The equivalence point is when the solution from the burette becomes the excess reactant, when we're changing what is limiting and excess. Those moles being equal or equivalent is really important. We use molarities, we use a mole ratio from a balanced equation, and then we either use the volume or the mass to find our final unknown. There is a special shortcut that can be used in these circumstances of doing a titration with two solutions that are acids and bases. We can do this variation that's right here on the dilution equation. The molarity times the volume equals the molarity times the volume, but we have to account for the balanced equation. Normally in a dilution, we're just adding water without changing what chemicals are in there. In this case, we are thinking about how the moles of one thing is equal to the moles of the other, and that's only true if the hydrogens released by our acid is equal to the hydroxides released by our base, or by accounting for the number of H's in the formula of our acid and the number of OH's in the formula of our base. So in the calculations, I do it both ways, using the full method, which is the best way of doing it, molarity to moles, mole ratio, solving for your unknown, but also do connect to how this equation can be used with some examples of when that's an appropriate shortcut.